In this video, we'll cover dimensional analysis, which is a powerful problem-solving strategy that can help you with conversion problems and answering questions like those listed here. Dimensional analysis is often used to analyze and solve problems using the units, aka the dimensions, of a measurement. It's powerful and flexible, and it involves changing a measurement and its units into an equivalent measurement with a different unit. It uses equivalent measurements called conversion factors. In the example here, where we're trying to convert 75 nickels into quarters, the conversion factor is 4 quarters over 20 nickels, because 4 quarters is equivalent to 20 nickels. These are the steps of using dimensional analysis. If you know how to do these steps, you don't actually have to know how to solve the problem. Just do these steps, and the dimensional analysis will solve it for you. Step 1, write the number and the unit you're trying to convert from. Step 2, multiply by a fraction. That's your conversion factor. Step 3, write the unit you're trying to convert from, the one you're trying to cancel, on the bottom of the fraction. Step 4, write the unit you're trying to convert into on the top of the fraction. Step 5, fill in the numbers that go with each unit of the conversion factor so the top of the fraction is equal to the bottom of the fraction. Remember that when the top of a fraction is equal to the bottom of the fraction, it's essentially just a funny looking 1. For step 6, you perform the calculation, multiplying all the conversion factors on the tops of fractions divided by all the conversion factors on the bottom of fractions. Let's look at an example together. How many grams of medicine are in a 49,500 milligram tablet? For step 1, shown in white, we write the number and the unit we're trying to convert from, 49,500 milligrams. Step 2, multiply by a fraction. That's shown here in green. For step 3, in yellow, we're going to write milligrams, the unit we're trying to convert from, on the bottom of the fraction. For step 4, shown in blue, we're going to write grams on the top of the fraction. For step 5, shown in red, because 1 gram is equivalent to 1,000 milligrams, and I can remember that by writing 1 gram and moving the decimal 3 places to the right to get 1,000 milligrams, King Henry danced, usually drinking chocolate milk. Since 1 gram is equivalent to 1,000 milligrams, step 5 is complete. For step 6, we're going to multiply the 49,500 times 1 divided by 1,000. That's 49.5. The milligrams cancel out of the calculation because we're multiplying by mg and dividing by mg. But grams, the unit we're trying to get, did not cancel out. That's how we know we did it right. 49.5 grams is equivalent to 49,500 milligrams. Now it's time for you to practice. Pause the video at this point and solve each of these 4 problems using dimensional analysis. Then resume the video and you can see my solutions. For step 1, we'll write down the number and the unit we're trying to convert from. Step 2, we multiply by a fraction. For step 3, on the bottom of the fraction, we'll put the unit we're trying to get rid of. And on the top of the fraction for step 4, we'll put the unit we're trying to get. For step 5, I need to write an equivalency, a conversion factor. 1 kilogram is equivalent to 1,000 grams. I know that because King Henry danced, usually drinking chocolate milk. If I have 1 kilogram, I move the decimal 3 places to the right, and I get the number of grams, 1,000. For the final step, we multiply 3.1 times 1,000 divided by 1, which is 3,100 grams. The units kilograms canceled, because you're multiplying by kilograms and dividing by kilograms. The only unit that didn't cancel is grams, the one we're looking for. Slightly different, but the same process applies. I have 78 grams that I'm trying to convert, so I start by writing 78 grams of gold. Then I multiply by a fraction. On the bottom of the fraction, I'm going to put the unit I'm trying to get rid of. On the top of the fraction, the unit I'm trying to get. Now, in the problem, I'm told that the density of gold is 19.32 grams per cubic centimeter. This is a conversion factor between grams and cubic centimeters. 19.32 grams is equivalent to 1 cubic centimeter. 1 cubic centimeter is the same thing as 19.32 grams. This conversion factor is just the density written upside down. 19.32 grams is equivalent to 1 cubic centimeter for gold, and 1 cubic centimeter for gold is equivalent to 19.32 grams for gold. Now I multiply 78 grams times 1 divided by 19.32, and I get 4 point bunch of other digits. We're going to round to something reasonable, like 4.0, because this number only had 2 digits. 4.0 centimeters cubed. 78 grams times 1 divided by 19.32 grams. Grams cancel. Centimeter cubed didn't cancel, so there's our answer, 4.0 centimeters cubed. Here's a problem where I need to convert 13 minutes into seconds. So I'll start with 13 minutes. We'll multiply by a fraction. On the bottom of the fraction, we'll put minutes that we're trying to get rid of, and on the top, we'll put seconds that we're trying to get. Now, 1 minute is 60 seconds. So 60 goes on top with seconds, 1 goes on the bottom with minutes. Minutes cancel. Seconds is the only unit that remains. 13 times 60 divided by 1 is 780. 780 seconds. Let's convert 355 milliliters into fluid ounces. And we're told here that 29.57 milliliters is equivalent to 1 fluid ounce. That's our conversion factor. But we start with step 1, 355 milliliters. Step 2, multiply by a fraction. Step 3, we'll put milliliters on the bottom because that's what we want to cancel. And we'll put fluid ounces on top for step 4 because that's what we want to get. Step 5, put a number up here and down here so that what's on top is equal to what's on bottom. According to the conversion factor, 1 fluid ounce is 29.57 milliliters. Milliliters canceled. Fluid ounce is the only unit that didn't cancel. That's how we know we did the dimensional analysis right. And then we can take our calculator, 355 times 1 divided by 29.57, and we get 12 point a whole bunch of digits. But we're going to round to something reasonable. Because this number only had 3 digits, I rounded to 3 digits. 12.0 fluid ounces. Now you know how to use dimensional analysis. Have a great day.